Hello, good day everyone. My name is Garth Montayo and today we're going to solve a problem which is related to the ULO Unit Learning Week 17 to 18. So the ULO 17 to 18 tackles about the uh, tackles about the subject of double integrals and triple integrals. So as per requirements, we're going to solve a problem that is related to this topic. So the problem that I have provided is a double integral. So I'm going to show you the process on how to solve these problems. So before we go to the proper solving, let's read first what is the problem. So, problem, evaluate the double integral 2yx squared plus 9y cubed dA, where D is the region bounded by y is equal to 2/3 x and y is equal to 2 square root of x. So, before we're going to solve the problem, we need to unravel first what is the meaning or what is required for this problem. So the dA here requires the region bounded, which is the area. So the requirement is the area. Okay, let's graph first the region bounded by the integral, which is y is equal to 2/3 x and y is equal to 2x. So let's graph first. Okay, let's have a Cartesian plane here. This is the y-axis, x-axis. Next, we're going to have a line here and a curve here. Okay, so this is y equals 2 square root of x, and this is y equals 2/3 x. Okay, next is to find the x. So the reciprocal of dy is equal to 2x is 1/4 y squared, that. And the reciprocal of 2/3 x is x equals 3 squared y. Okay, now that we have this graph, this representation, this will be the area that is needed to find in the double integral. So the next step that we have to do is to find its limits. So by finding its limits, I have here the limits of the integral 2yx squared plus 9y cubed dA. Okay, so the limits were 0 is less than equal to x is less than equal to 9, and for the y, 2/3 is less than 2/3 x is less than equal to y, and is less than equal to 2 square root of x. So our expressions now will change. So from this, it will be transformed into this. Okay, then 2yx squared plus 9y cubed. Don't forget dy dx. So this will be the basis of our equation now. Okay, before we go to the integration stage of our problem, so we need to first clarify which will be the first thing that we need to do before proceeding to the next step. So this area here should be the first one, while this area here should be the second one, because before we get to the final step, we need to first extract or integrate the first we need to integrate first the dy, then next the dx. So let's solve this problem here. So 9 integral 2 square root of x 2/3 x 2y x squared plus 9y cubed dy dx. So as per required by the equation, we need to first solve or integrate this part, the dy part. So let's go. 9, 0. So the integral of 2y x squared plus 9y cubed dy is, so 2y squared, 2y x squared will going to be y squared x squared plus 9y cubed will produce 9 4y 4 if it is integrated. So after we have done that, we need to evaluate this definite integral. So 2 square root of x and 2/3 x dx. Okay, now we need to evaluate. Okay, we need to first evaluate 2 square root of x and replace the x's here, the y's here with this one. So y. Okay, now we need to solve this problem. Okay, then the next thing that we need to do is for x squared plus 9/4 16 squared, yan, minus 4 9 x squared plus 9 4 16 over 81x for the x. So this is now our expression. So to solve that, to further simplify the problem, we need to simplify it in terms. So what must be multiplied will be multiplied, what must be divided will be divided, what must be added will be added. Okay, so this is now the product. 36x squared plus 4x cubed minus 8 9x 4 dx. So this will be the product of this one. So yeah. Then to proceed to the next is dA is equal to 36x squared plus 4x cubed minus 8 9 x for dx. So the integral of 36x squared will be 12x cubed plus the integral of 4x squared x cubed will be x raised to the power of 4, and the integral of 8 raised to the power of 9 x raised to the power of 4 will be 8 45 over 45 x raised to the power of 5. Okay, now that it is integrated, we need to evaluate. So let's put the 0 here and the 9. So we just need to change all this x's into 9. So 12 so 9 cubed plus 9 4 minus 8 45 9 raised to the power of 5 minus 0. So the answer would be 24,057 over 5. So 24,000 over 5 should be the answer, or we can simply divide it. So 24,057 divided by 5 will be 4,811 remainder 4, or 4/10. So this is the answer. Okay, so I hope you understood the double integral, and thank you.